Hello, everyone. Thank you for joining us. We're going to be waiting a couple of more minutes for people to join us, people that are trickling in. But thank you very much for being with us here today in our new webinar episode. We have something quite special for all of you cement manufacturers, and we hope you share the enthusiasm. We're just going to wait a couple of more minutes until 5:03, 5:04 before we get into it. If you are in, feel free to say hi in the chat. We hope you have some questions ready for us. And if not, perhaps some will pop up in your mind by the time we're done showing you the presentation. We're almost ready, a couple of more minutes, and we will start. We also have something pretty special for anyone who sticks around until the end, which I will reveal at the beginning of the presentation and then give you more details at the end. All right, we're going to wait just one more minute and then we will go. Ready or not? It's the end of the day here in Europe, so not surprisingly, some people are coming in a little bit late. We're just going to give them a chance to be with us from the get-go. All righty, I think we can start now. Welcome, ladies and gentlemen, to another Wizato webinar. Today, we'll be presenting optimizing cement production for all of you cement manufacturers joining us. Thank you. My name is Filip Popov, and I'm joined by Albert Comillas, our lead data scientist. He specializes, there you are, Albert.
Hello.
He specializes in optimizing and integrating artificial intelligence within cement manufacturing facilities to help drive anomaly detection and process stabilization. Today, we have a special gift also for those who stay until the end, a free feasibility assessment for anyone looking to integrate AI within their production. So stick around for more details on how you can be part of this feasibility assessment and start your AI integration journey. So let me tell you what the structure of today's presentation is going to look like. So first, we're going to discuss industry challenges and how our company addresses them, followed by a short background. Then we'll have the main value drivers of AI integration in cement manufacturing. And that's when we're going to sink our teeth into a deep dive into a specific case study. In this case, increasing yield on horizontal mills using AI. And last but not least, as promised, I'll give you details on how you can apply for the free feasibility assessment, following which we'll have a Q&A as customary. So let's start with some of the challenges in the cement industry that open up opportunities for AI integration. At this point, it's clear that AI can significantly improve and optimize production and business processes. On the left side of the presentation, you can see common questions about integrating AI in production. Questions like, where do we start? Of course, this is the crucial point because the data is the foundation of a successful artificial intelligence project. And once you've answered that, what assets, the second question will be, what assets should we optimize first? It's very important to know your why and which assets we're working with and which processes we want to actually optimize. We work a lot closely with clients to identify what are the assets and processes that we should start working with, and then what are the ones to follow. And that's the best practice, is to collaborate together with the actual business owners who know the business best. Naturally, once you have a successful deployment on one of the processes, the following question is, how do we scale the solution to other production lines and other assets and other facilities? This is where a lot of pilot projects go to die, regretfully. Unlike in cases where without that, we can actually help our clients scale those solutions. So Wizata really has a feature to help scale AI models and AI solutions across the whole production, as well as across different sites seamlessly. Last but not least is, how can we measure the impact and ensure successful deployment, which is, of course, very important. In fact, the very important driving idea behind even deploying AI is to, in the first place, is to reduce costs, right? And ways to measure it. And it's important to have ways how to measure that. On the right-hand side of the slide, you can see our answer to these questions. Wizata is a SaaS company providing a solution to help build, deploy, and operate and scale AI. And together with the support of our data science experts like Albert here, we help manufacturers have a successful AI application from pilot to scale up. On top of that, we offer you, our dear audience, a way to check whether your production process would be a good fit for AI application at the zero risk for you with our feasibility assessment, which I will give you more details on at the end of the presentation, so please stick around. We are based in Luxembourg, but have a global presence, as you can tell. We've delivered projects on nearly every continent, save Australia. On the right side of the slide, you can see some of the projects we've worked on and continue working on. Here you can likewise see the companies, or company names, of course. What can AI achieve in the cement industry? Some of you may be wondering right now if you haven't started on this journey already. And here are the three main areas, starting from left to right. So predictive maintenance is one of the most important value drivers, and apply to feeders, roller presses, pumps, ID fans, to ensure reliable and increased lifespan of said assets. The second, but not any less important deliverable, is increasing the yield. So optimizing mills and kilns, excuse me, to boost production output. Very clear return on investment there, right? And of course, energy saving, reducing energy use in rotary and vertical kilns and entire production processes. Since we can't cover all of the cases in this webinar, we'll focus on a specific case study of using AI to improve yield on a horizontal mill. So using AI to improve yield on a horizontal mill will be the one that will be deep diving today. So let me paint you a picture. We had a challenge where an operations manager wanted to maximize the feed rate, excuse me, while keeping mechanical conditions stable. Our approach involved building a recommendation system for 3 critical set points. The outcome included real-time recommendations, data-driven automation, real-time alerting, and dashboards for information consumption. Al, could you enlighten us on the model consideration?
Of course. So just let me say we are under an NDA, so I would say that without going too deep into the details, the broad idea of the approach we took behind this model was that, so the goal was increase the yield of this mill while keeping the mechanical conditions stable, say vibrations, pressures, and a certain limit. So what we did initially was to discard from our data all the cases that didn't have the desired conditions we were looking for. Once we had the data set with the, say, desired conditions like high production, stable operation, we extracted what were the most relevant set points combination for each of the cement types that were produced that made these desired conditions possible. And once we have identified these relevant combinations of set points, we train another model to identify in real time, depending on the context we are in, which is the set point combination that right now will make possible having a high yield while keeping the conditions stable. And in addition to this, we also developed an anomaly detection system dedicated to the auxiliary systems of the mill, which are the lubrication system and the hydraulic system for the mill.
Perfect, thanks. And I suppose the most important part is the business impact of this solution, where we managed to achieve actually a 10% yield increase on the mill. So that's pretty fantastic. So let's dive deeper, Albert, as to how we achieved this in the next 6 steps, starting with data connection. Can you explain how we connect data to Wizata?
So in fact, there are many ways that we can connect data to Wizata. So since each client has a different architecture and different data source, we have to be as flexible as possible. So we can connect to existing databases, condition monitoring tools through APIs, or directly to the production, to the PLCs. So what we typically do is we collaborate together with the IT teams and the automation team of the client to find the best solution with them while complying with all the security protocols, of course. But the connectivity, it has never been a blocking point. Let's say we always find a way with the client. In this, as in the particular case of the mill, we started connecting to an OSIsoft PI server, and then when we had to write the recommendations to the machine, we did it through an OPC UA server to write the values directly to the PLC. So then once we have the data connected and the data is flowing in real time, we continue by contextualizing this data with the production process. So we define the production process in our data hub, that is what you see in the screen, using a drag and drop interface to create the layout. Even if you have a SCADA system, you can make an export and we can pass this information to generate the layout automatically. And when it's set up, the data hub allows you to visualize the live data, the live information that we have connected, including some metadata about the process, operational parameters, or quality measures. So let's say once the data is connected and the layout is ready, that gives us the starting point to give it content. So then it can be by applying, in this case, a recommendation solution or a predictive maintenance, whatever it is. All the resources we generate, say all the models, all the visualizations, then are attached to the item in the data hub they belong to. So this way, all the information is organized within the platform, And ultimately, this also allows to give the user permissions depending on the hierarchy in the data hub. So if you want a user to only see what happens in a certain plant or in a certain area of a plant, depending on their area of work, so that's possible to do thanks to this hierarchical structure.
Gotcha. So the takeaway is that we can connect with any kind of architecture that's available, basically. But so, okay, so once you've covered the first step, the next step is analyzing the data, right? Once the how do we analyze it? What's important in this step?
So once we have clarified the scope and the goal we are pursuing, like in this case, generate recommendations to maximize the yield. Something important when we start developing a case is to count on the support of the business experts, because nobody knows their processes and their machines better than them. So their guidance is really priceless for us to really focus on what really matters. And it can also work the other way. So we can find patterns in the data that we can revert back to the experts, and they can check if they make sense, and like that gather knowledge about their process. So with that said, when it comes to analyzing the data, the Wizata app provides a data explorer to visually explore the data. So play with time windows, with aggregation functions, types of plots, histograms, time series, scatter plots, even fit regressions. And ultimately, you can also make your computed data points either in Python, so writing the logic of this computed sensor in Python, or if you don't have coding skills, you can also use these logic blocks that you see on the right of the screen to generate your own calculations.
Excellent. So, Albert, we've collected the data, we've analyzed what's important, we've removed all the noise from the data, right? And we've worked with the business owners to understand what's important, because, as you mentioned, nobody knows their production in machines and machines better than them, right? Now it's time to get our hands dirty, to start building the model. What tools do you use, and what challenges might one face without Wizata?
So sometimes visually it's not enough. So the case we want to solve is more complex, like it was this case to generate recommendations of set points. The Wizata platform, what we have at Wizata, is our Python library that allows us to communicate from Python to the Wizata platform. So all this is to bring this analysis into Python, leverage all the almost limitless possibilities Python offers in terms of cleaning data, manipulating the data, training your models. And then when you have everything ready, all your codes and all your trained models to execute your solution, you can register all this back to the platform. Basically, all you need to execute your logic, register into the platform, and then put all the pieces together to form what we call a pipeline, an execution pipeline, that is the flowchart that you see on the right. So that's all the steps, queries, codes, model calls to execute your solution, in this case, to make recommendations. So the logic, the pipeline on the right is to execute the logic of this solution that is on the left. And so this will generate the recommendations. It's also important to mention that then also the platform offers the triggering capabilities to generate these recommendations, or to execute this pipeline when it's needed. So depending on the case, it could be every 10 minutes or when a certain condition is met, etc.
Perfect. Okay, let's bring it back a little bit for us that are not AI experts like yourself. Once you've developed that, right, where does the user and how does the user actually get that information to them? How do they consume it?
Mm-hmm. So we built at the beginning the layout of your production process in the data hub, and we said that all you produce, you assign it to the item in the layout they belong. So in this case, the most common ways to consume the results of this model is via visualizations, say dashboards, and also alerts and notifications when needed. So in this case, what you see is all the different solutions we have deployed, in this case, in our demonstration platform under Cement. So here you would see in these tiles, the dashboards for all the solutions related to Cement. So that's how the information is organized and easy to consume.
Gotcha. On the next slide, I know we have a dashboard. Can you give us a ride through this dashboard? What are we looking at, and why did you choose these widgets to display?
So dashboards, of course, are customizable depending on the case, on what we want it to show. In this case, for the cement mill recommendation case, so what you see at the top left, these three gauges are the three present values for the recommendations for the three set points we are recommending. Right below it, this bar chart in greenish, this is the evolution of the mill yield for the last 12 hours. On the right of it, this 7.3 is showing the gap between these 12 hours, so the increase of 7.3 tons per hour. Up on the right, there are some present values also to follow how is the production going. So it's telling the cement type is being produced right now, the current production, and the energy consumption. And at the bottom, right, where you see this okay, no okay, this is the outcome of the anomaly detection system. So the two okays are the auxiliary systems, the lubrication and hydraulic system. And you also see a not okay. This is in fact coming from a different analysis on the motor. That is the result of a vibration analysis on the motor. It's a case aside of the recommendation. This is to show that in a dashboard we can combine and display outcomes from different executions to have an overview of how is the production going.
Thank you. Very cool dashboard. Love it. Now, in the next dashboard, naturally, we need to make sure that all this is running right and that we increase the lifespan of the machines. And we do that through some predictive maintenance capabilities of the platform. So this is a dashboard that shows that, correct? Can you also explain us what we're looking at here in this dashboard?
So this is how we saw before. The motor is not doing okay. So that's how we would continue the investigation. So we can navigate from that dashboard to this dashboard where we can drill down on what is the motor condition. So this is the outcome of the vibration analysis on the motor. And it tells us that the status is poor right now, and it's giving it a score of 4.55 out of 10. We have this bar chart where there are the likelihood of the different failure modes. So what is the failure mode more likely to be happening now that makes the motor unhealthy? And even we also see some recommendations, some actions to take to mitigate this problem. So this would continue the investigation of what's going on with the motor and linking our case of mill set point recommendation to another case of vibration analysis.
And naturally, if things are starting to go wrong, we have an alerting system. How do we set up an alerting system?
An alerting system is easy to set up. Say, only thing it needs is a binary variable that when it's 0, nothing happens. When it's 1, it will send us an alert. So having this variable, we just connect it to what we call an alert block in our platform. And here you will just configure this alert block to define if we want this alert by email, by SMS, and which is the text and the subject of this email. So basically now every time this variable turns to 1, meaning that there is an anomaly, we will receive this email with the text we specify here.
Okay, amazing. All right. So let's review what we just did. Okay, we've connected the data, we've analyzed it, created a model, and deployed it. We created the dashboards, which are connected back into the data hub, and alerts for the system in case something is going wrong. And we've developed all that for one mill. So the only thing that's left is to actually scale and deploy that on multiple mills across all our production site, correct? So how do we do that with Risata, and how does Risata help you scale? I guess, how would you do it if you didn't have it, let's say?
Mm-hmm. The Wisata platform, one of its main capabilities is to offer a comprehensive standardization for the deployment and the scaling of AI models. So it simplifies the whole automating process. Wisata simplifies this by providing templatized solutions, which will include the list of inputs, outputs, and configuration parameters your solutions or your pipeline needs to run. In this way, when you want to replicate a solution from one asset to a new asset, all you are asked is to fill out this template of inputs and outputs for the new asset. Additionally, Wisata also features templatized dashboard. So as you scale your solutions, as you apply your model to more assets, also you replicate with it the dashboards to visualize to consume the results of the model in the new asset. Like this, you can leverage your efforts, the resources spent into developing one solution for one asset, and apply it to several other assets that have similar characteristics. Without Wisata, so you would need to manage all these steps of the deployment and scaling manually, which would be deciding on how to connect to the data source, define the input and output, and in which format you interact with them, the version control of your codes, the containerizing of your solution, the deployment to the target environment, Python environments, the performance to execute the solution, the triggering system, configuration files. So all these for each deployment. So defining all this is until it's robust, it can be error prone and time consuming, not only to do it, but also to bring all the people involved and take the, the agreements and the decisions together. So basically, Wisata, the platform, helps you by taking care of all these aspects for you.
Yeah, it does sound like quite a headache. No wonder a lot of AI initiatives kind of fail after the pilot project. So in conclusion, we're basically saving a lot of time and headache for data science and automation teams and the production teams, and the impact it has on the business is that operational costs go down. They can do a lot more with a lot less effort. And of course, the more stuff that they have running, the more value they have. So thank you, Albert. In summary, to give our viewers an idea of the timeline of the deployment of such solution, it all starts with the data connection, which takes about 2 weeks, followed by research and deployment. That means integrating AI, creating and evaluating models, and finally scaling, which takes about a month. In total, about 6 months from start to finish, and start realizing ROI. If, however, you're still in doubt and on the fence and have stuck around until right now, we're offering a free feasibility assessment, as promised. This is an opportunity for you to evaluate our tech and expertise with your very own data and have much better understanding of the potentially achievable ROI at zero risk for you. What we need to start is to have a sample of your historical time series process data with 6 or more months historical data, which we can integrate, visualize in Risata as a first step. And as a second step, we can analyze it to show where we can find anomalies. last but not least, we can assess the business impact of the anomalies together with you and recommend AI applications. So that way you have a much better idea and feel of what the potential impact it is for you and whether your process data is enough. So reach out to me via LinkedIn or via email, or book a meeting directly with the booking link on LinkedIn for more details. And we can organize this feasibility assessment in a customized demo for you. Thank you everyone for the attention. I want to open the floor for Q&A in case you have any questions before we wrap it up. Don't be shy. I know Albert is a very intimidating guy, but he's actually a sweetheart when you get to know him. Alrighty, so for the feasibility assessment, how do I send you the data? So there's multiple ways we can go about it. Either depending on the size, we transfer, or otherwise we can provide you with a cloud instance where you can upload the data, or you can provide us with a cloud instance where you can upload data and give us permissions to download it. So yeah, I hope that answers your question. For more information, honestly, we can get on a 15-minute call and I can give you exact details and the format which would be preferred. This one's for you, Albert. What is the difference between your AI recommendation system and expert system?
Let's say both of them pursue the same goal, which is assisting in the decision making in an industrial environment. I would say they are complementary, so they are same things but on different ends. So expert systems are based on rules; they are more static, based on expertise of the business people. But it has the good thing that is easy to interpret because it's based on rules, so you can understand why it's behaving in a certain way. AI, it's on the other end. It's more flexible, it's adaptive. It's based on data more than in expertise, but sometimes it's more difficult to interpret. So I would say they are complementary. So if an expert system is running on a system and it's running fine, there's no need for more. You have an easy system, easy to understand, easy to correct. If there is margin for improvement, then I think an AI or data-driven based solution can be a good thing to try.
Thank you, Albert. Anything else from you? Okay. How much did this project cost? So the project will vary in terms of pricing depending on the scope, which is determined by what we're trying to achieve, as well as how much data we have involved, which will determine how much actually of our work or our platform's resources we need to make available. But a project like this, I think it's safe to say that it's somewhere between 50 and 70,000 euros. Which, once put in perspective, like a 10% increase in yield, it's pretty good ROI, I would say. All right, we'll have a 1 more minute open Q&A session. So if you have any questions, please feel free to write. Don't be shy. And if you are shy and you still have questions, then feel free to write me personally on LinkedIn. All right. Well, thank you everyone for being here, for watching our webinar, for joining us today. And if you want to connect and see what we can do with your data, don't hesitate to reach out to me, and hope to see you in our next webinar. Have a great day. Goodbye.
See you.